Jain everybody. Now today we would be discussing the next component of the blockchain system, that is the mining. So what do we mean by mining? Basically the miners are nodes which are called, miners are called in, first of all the miners are called in Bitcoin. Miners are the words which are being used in the Bitcoin, and forgers are the word which is used in Ethereum. Now what is Bitcoin and Ethereum? These are the cryptocurrency which are being used nowadays, from which the blockchain came into picture. So what does these particular person do? They validate a new transaction which is being done and add that particular transaction to the blockchain distributed ledger. Okay. Each and every transaction is being recorded there. So these particular miners or the forgers, they compete with each other. They fight with each other. Who would be the winner? What do they want to do? They want to solve a complex mathematical problem, and that particular problem they have to solve using the cryptographic hash algorithm, the algorithm which we have discussed in our previous videos. So obviously hashing is a very secure cryptographic functionality which we are using here, and there we have generated the hash key. Assume this particular H2 is the hash key which was generated. Now I am sending a nonce, as we remember that are the random numbers which are being generated, and that depends what number do we want. So we can have a number from between 0 to 100 or 0 to 10, 0 to 1. It may be up to 4 decimal places, any random value which cannot be regenerated again unless and until we run it again thousands of times the same algorithm. So we have a nonce associated. Let that particular nonce is also N2 here. So again we use a hash function to do it, and we generate a new hash key for this particular message. The message is X. So I'm generating a new hash key for message X, for which we have generated a hash value H2 previously using the hash cryptographic hash function. With the nonce, again we are using the hash value and then generating a new hash value which is being sent by the miners or the forgers to everybody. So here the complexity is, we were having that particular Markle tree in which there was a hierarchy of all those particular hash functions. Then again the output which we are having, we again hash it with the help of again a nonce which was generated. So that is where the complexity of this particular algorithm stands. So how complex this particular is, think about this. When you're trying to listening or hacking some data, what all things you have to keep into mind? Because nowadays this mining work has become a new startups, because we in miners we don't require much of the things. What is, I can have approximately an area of a flat, and I should have high computing power systems. In short, I should have supercomputers. I should have cooling system in that particular area. I don't require much of the things. Cooling system. I should require a high speed computational power supercomputers, and the persons who knows all these cryptographic secure functions, so that they can act as a miners in that particular blockchain system. So there are some constraints for generating this particular mining or that particular value. So what this particular hash value has some constraints or some limitations what we have to take into consideration. We have to see the hash value which is being generated by the miners. I usually use the word miners because the Bitcoin has given that particular word miner. Forger is the word which is less frequently used in blockchain also. Okay, so we would be using the word miners as a component of this particular blockchain. So the miners, they have to look into it. If this particular previous hash value of the previous block, assume that value is the target value, and that value was 36. So I have to generate this particular new hash key which should have a value less than 36. That is the first constraint. So you should have a resulting hash value that is less than your target values. The target value is obviously a number. That hashed block header must be less than the new block which is being over. If this is 36, you can have 35.9 also, it is less than 36. Or you can have 3 also. But we usually keep the number around this target value so that we can generate new blocks from that particular values. So the target value is, we have to have a value less than the previous block. Obviously, that is the target, and we have to reach that particular target. When we reach that particular target, that is this hash value is reached, then I can say that I have generated a hash key which is less than 36. So look into it. I broadcast that particular value to everybody, and then I become the winner, or I become the miner of that particular blockchain. How this mining is being done? So if a hash value, see, if I tell you that P1 is a person which tells that it has to transfer some amount to P3. Let that be rupees 1000. Okay. So what if I have P2, P4 and P5? 5 persons I have in my blockchain. I'm considering only a small blockchain with 5 persons. So in this particular blockchain, P1 is telling that I want to transfer rupees 1000 to P3. So along with P3, P2, P4 and P5 would start validating if this P1 is a member of the blockchain. Yes. Okay. First thing. Second question which they find the answer is P1 having balance greater than equal to rupees 1000. If this answer is also yes, then P1 can transfer money to P3. So first thing, in short, what they are doing it, they are validating the user. They are validating the user. Okay. After validating, whenever he tells, yes, now this transaction can take place, all of these P1, P2, P3, P4 and P5 in a normal blockchain system compete to find this particular cryptographic value. They start doing it. Anyone in this particular network, if the target hash value was 36, any one of these who can generate a value less than 36 becomes the winner of this particular blockchain. If it is even 35.9, who is the first one becomes the winner, and that particular person is called as miner for that particular transaction. Okay. And that value is being broadcasted to, if then that particular hash value is being used to create a block, and that block is being added to our blockchain. That is the one thing. Okay. So what we have done, we have seen a hash value that is not less than or equal to the target value, and the miner has to, if that particular value is not less, if I'm trying and I'm getting a value, if P4 is trying and it is getting a value of 38, P5 is getting a value of 65. So how would they target? They have the same hash value. They have the same timestamp on which time they are doing it. Only the thing which they can change is the nonce, that is the random number. So each and every time they are failing to reach this particular value, they try to change that particular nonce. If the value is very high, then they try to decrease the nonce. If the value is very low, they try to increase the nonce. It depends. Okay. So we have to see if that particular target value is not, we are not getting a value less than the target value, we have to change only the nonce. We cannot change anything else. Only timestamp, obviously it is taking from the system, it is getting changed. But we cannot change the customer number, we cannot change the transaction ID, we cannot change the previous hash value. So what we can change, the current timestamp it would be taking for generating it. Obviously for everyone that current timestamp would be approximately same, a little difference in the milliseconds may be there. And next the nonce. So they have to do all those things on the nonce. And the process is run multiple times so that we can reach a value less than this 36. Once a solution is reached with a value, and I told that if P4 becomes the winner, that it has generated a value, if P4 becomes, it has generated a value 35.4, which is obviously less than 36. Now he becomes a winner. So once a solution is found, a new block is being added to the network, and it is being propagated. Propagated means it has to be sent to each and every person in this particular blockchain. A minor node has to compete to solve this particular problem, and so they require massive computing power, energy and time. As I have told, when you have supercomputers, obviously you are using more computing powers, you have more computational speed also, and you are using energy also, because that supercomputers require more electrical energy to run. They require less timing, but similarly they would require more electricity. If that particular area gets heated up, you require a cooling system to cool that particular area, otherwise the supercomputers will go down. So we have to see, along with the computational power, there comes a trade-off, the electrical energy. There comes a trade-off, the heating system, the cooling system which we require for this. The person who is the first to become the winner, that particular person will receive rewards. Those rewards can be in terms of some fee which is being given by that particular blockchain, or a new Bitcoin. Usually this concept of the blockchain came into 2009 with the Bitcoin. So Bitcoin was the cryptocurrency which was launched, which used this particular blockchain architecture. The blockchain architecture didn't came as a different architecture. Then Ethereum came, then there are different generations of this particular blockchain. So as and when it evaluated, we came to know that this blockchain environment is very secure, tamper proof, it has integrity, it has security, it has privacy. So we can use it for other applications also as compared to the cryptocurrency. So we shifted from that cryptocurrency to a architecture design, and that was the blockchain architecture design. So in some of the videos, whenever you would be reading this, they would be telling in somewhat in terms of the Bitcoin. So it's not always necessary that these are the Bitcoins which we are giving it. It can be some transaction fees also. It can be in terms of the fee which that particular person is getting in terms of being into that particular, or the miner of that particular transaction. So next is when we are doing a mining, what do we have? When we are doing mining, then we usually have that we should know who is the winner and what all transactions we can do it. Okay. So next is, what do you mean by consensus protocol? So consensus protocol, what do you mean by protocols? Protocols are basically the set of rules which we have to follow while we are in any of the system. Okay, if we are taking any home as a system, then we have to follow some of the rules in our home also. So the set of rules and regulations which we have to follow in a certain domain is called as the protocol. As the consensus protocol, we should have a set of rules whereby nodes in the network can achieve agreement on what data value they are reaching it. What is the state of that particular network? The hash key which I am telling you. So we have to see on the data values, on the state of the network, that it benefits the network as a whole, and we does not focus on individual interest. As it is a distributed environment, we have to see in the distributed environment, each and every person is equally likely to have equal rights to each and every person. So for equal rights, we don't have focus for individual interest. It should be decentralized. So in the decentralized world of blockchain technology, all participating nodes must agree on a single source of the truth. When they agree on that particular point, they have the same opinion on that particular point, then that point can be taken or carried forward. Okay. So for example, if you can take that if Alice has sufficient amount of money in her wallet, then she can continue with that particular transaction, or she cannot do the double spending if she don't have the money. So all these particular nodes should come to a common consensus. Here we have taken the example of this when we were having 4 users and P1 wanted to send money to P3. So we have validated this particular user. In validation, What you have seen, we have seen that that particular user belongs to the blockchain or not, if sufficient amount is there with the user or not. So all these four have a common agreement, common opinion about P1, then only P1 can do that particular transaction. So we should have a common, we should agree on a single source of truth, then only we can carry forward that particular transaction to be taken place in the blockchain. So consensus protocols are used in the blockchain to ensure that the transactions are valid before being added to the blockchain. This is the main thing. Once the transaction is validated, then only we can add that particular transaction to the blockchain. And there should be consensus or agreements between the nodes of the network on the state of the blockchain. So there are basically three critical functions which we have to see into the blockchain. One is the consensus protocol, which is being done. Second is the speed control between the nodes. What is the speed between those particular nodes? Then preventing any single entity from taking control and disrupting the blockchain system. Because we are using a distributed system, so we don't want, in distributed system, no central control. No central control authority should be there. Central control authority. So we don't have a central control authority, it should be there. So you should have a consensus rule that should aim, that you should guarantee that there is a single chain which is being used and which is being followed. So we should have, the aim should be, there is a single chain which would be used and which would be followed. So they are designed to be very costly. It's very resource heavy in terms of computing power, as we have discussed, and the time and efforts to take place in the network. Obviously, how do we do this particular thing? So when we are having particular miners which are working into system, see, I have taken an example here, how this mining takes place. We would be taking this into a bit detail. I have P1, P2, P3, P4 and P5. P1 wants to send some money to P3. Okay. So first step, what we have done validation of user. So validation of user is being done, that P1 is a valid user and can transfer money to P3. Now, what would we be doing? We would be creating a unique key using the hash functions. So all P1, P2, P3, P4 and P5 started competing among themselves. We have only 5. If I consider a normal Bitcoin blockchain network, then I have thousands of users, maybe 1 lakh users which are involved in that. So when a particular transaction takes place, maybe now the Bitcoin doesn't work on a single transaction but a group of the transaction. So whenever you have to generate a block, each and every user, all the 1 lakh users in that particular blockchain compete to become the miner, so that they can become a winner and their value generated becomes less than that particular specific targeted value. So you are using 1 lakh nodes computing power. Okay. So what you are doing it? You are using computing power energy of 1 lakh computers. Even from the 1 lakh, I have 10,000 supercomputers. Whole lot of energy which is being used in that particular thing. So that particular value which is there in terms of the energy which is being used, the computational power which is used is a massive computational power. When we are generating that particular power, using those particular computer processing power, we are generating massive amount of heat while we are processing that particular mining. So the heat which is being generated by heating of those particular computers is being cooled down by cooling systems. Okay. So see, what I have supercomputers. So these supercomputers work on electricity. Okay, and these cooling systems also work on electricity. So I'm using very much huge amount of electricity also. Okay, when I'm using this cooling system is giving something in the out to the environment also, as you might have seen AC working at your homes. So the heat which is being liberated by these cooling systems in the environment is also massive heat which is being given to the environment. So when we are having these supercomputers working to become the miners, they are using massive amount of electricity, a huge amount of computing power energy. Along with these supercomputers, as they are processing much, they are liberating very much extremely, they are becoming hot and creating that particular environment as hot. And now what they have to do it, we have to cool those particular environment, otherwise my supercomputer would crash. So what we have to do, we have to use the cooling system. Again electricity is being used, so we are using 2 times the massive electricity for becoming that particular miner or the winner in that particular blockchain architecture. Then these particular cooling system are liberating energy in the environment also, and that is creating a problem of global warming. That is creating a problem of global warming. So these miners are creating so much heat and liberating that heat in the environment that it results in global warming. And so we can have many natural disasters coming out in near future because of this global warming, which is taking place in the cryptocurrency domains. Okay, so this is one of the drawback of becoming a miner or a part of the blockchain system. That is, first we have to invest money in supercomputers. Second, I have to invest money in cooling system. Third thing, I have to invest money to get high electric powers. These won't run on your normal house electric meters. They require commercial ones. So obviously, the money investment is computers. Second, the cooling system. These are all hardwares. Third is the electricity. And then the resultant again, what they would be doing it, they would be liberating heat in the environment, which is creating a global warming. So how these miners generate money? As we have discussed, these miners are given some amount of rewards, and these rewards are in terms of when we are doing that in the Bitcoin, then these rewards are usually in terms of Bitcoins. Okay. When I'm not using any cryptocurrency but a normal blockchain architecture, then these rewards are in terms of transaction fees. How we get these particular transaction fees? When P1 is telling that I want to transfer money to P3, obviously P1 and P3 would be giving some transaction fee to this particular blockchain network. They would be giving some transaction fee, both of them, the sender and the receiver both. They would be giving some amount of transaction fees. Okay. Assume that they are giving rupees 100 for each and every transaction which they are doing it. So from a single transaction, I got rupees 200. Okay. Now the miners are doing their mining, and the winner, which is only one miner, usually it is only one miner, we are giving rupees 50 to that particular miner. I'm giving rupees 50 to that particular miner. I'm earning 200, but I'm giving rupees 50 to the miners. So the earning of the blockchain is 150. So these particular 50 rupees, even a person is, even see if in all these particular blockchain, I have a P5, which is a passive person, or I should say, which is usually not doing any transaction. So he is a person who does not do any transactions. So if it doesn't do any of the transaction, but he only acts as a miner in this particular blockchain, he can own some of the money being a miner if that particular person becomes a winner in any of the mining process. So when we are having that particular miner as a output, then what do? We broadcast this to each and every person. That particular block is being broadcasted. So when we are doing this, we have a proof of work algorithm, which is called in Bitcoin protocol, and proof of stack, which is used in Ethereum. Okay, so the process of computing hash is called as the proof of work or the consensus mechanism, and this proof of work, which is also called as, it's POWO is small. POW provides integrity to the block, and adding a block to the blockchain without this particular consensus mechanism make it highly vulnerable to either the accidental faults or malicious attackers, because we are generating that particular highly secure values. Okay, so here we come to the end of all these component what we have in our blockchain. In the next video, we would be discussing about how these particular transactions practically take place, how do we validate this particular transaction, and how we have the miners in our systems. Thank you for this video.